Yeah, I hope my screen is visible to everyone. So let's get started
Yeah.
with Docker. So as already you know, Docker it's a containerization tool. So you know about containers, what is containers and why do we need containers? To give a quick idea about what these containers are, just assume that we have developed an application. Let's say it's a Java application or Python application or a .NET application or any node application to make sure this application runs same everywhere, like how it runs on dev environment, it runs the same in all other environments, like even test environment or production environment, without worrying much about configuration, installation and all the stuffs. So we use something called container. So what is this container? Before understanding Docker, we have to understand container. So container, it is a package. It is a lightweight package. So it is a lightweight package which has everything to run an application, which has everything everything to run an application, everything to run an application, run an application, such as um, such as you can say the source code and the configurations and library, the OS, and etc. Whatever needed to run an application, everything is packed as a container. So this container, it runs same everywhere. Um, Only the requirement is the container engine. It could be your Docker or it could be any container engine. You just have to have a container. Now what do you do? Let's say if I give you a Python application, so how do I deploy a Python application? Let's say I give you a node application or a JavaScript application or a Java application. How do we deploy an application? So first I get the source code. Maybe I can do git clone. Then I generate a build from that, or I compile the source code. I do testing. Then I set up my machine. So I have to set up my machine. I have to configure the environment variables. I have to get all the keys. If any API tokens are there, keys are there, then I have to download and install all the libraries needed or dependencies if there are any, in plugins if there are any. So only after that I will be able to run my application. So all of this stuff without containers, or if I just tell you to download, first you will create a server. So first you need a server. So you will a server, then you will configure the server, then you get the source code, then you install the libraries and dependencies needed, install libraries, sorry, download libraries needed, and if any dependencies, download the dependency, plugins, libraries, dependencies and plugins if anything needed. So all of this you have to do, then etc, whatever task is there, so all the tasks you will do, etc.
Excuse me, brother. One question. When you say create server, and I know Docker now, you mean create a platform in which to work on. Is that what you're implying?
Yeah,
Like a
so it
Linux
can be
box? That's what you mean. Oh, okay.
an
Or you should do
EC2,
instance. Yes,
a
yes.
virtual
Okay.
machine, or any server.
Or Docker desktop or something like that. That's what I practice with. That's
Yeah,
fine, right?
yeah, that's
Okay,
fine.
okay.
Like I'm talking before Docker or before the concept of
All we
containerization,
just
how we were
the
doing.
prerequisites, the prerequisites. Thank you so much.
Yeah.
I have one doubt. I want to understand between this Docker image and Docker container. I have a confusion.
Okay. Okay. Then that's valid. That's valid. So now I'll show you how the images are built and what is the difference between these containers and all. So now you got an idea. Container, it's a lightweight package which has everything to run an application. We have packed the source code and everything together, and everything is there as a package. Now you can think of it like a Maggie packet. So in India we have Maggie, right? So in previous days, like in early days, if I want to eat noodles, or yeah, if I want to eat noodles, so first you should make that, you should cook the rice and you should make that noodles, and you should prepare the masala, veggies and everything, then you will make noodles. But now we have 10 rupees, 15 rupees, 20 rupees packet. You bring the Maggie packet which is ready made, and you just cook with some water, right? That's it, everything is ready, just you will cook, right? That is how this container works. So back then we were doing everything manually, so now everything is packed, you just spin up, it's very easy. So why do we go for this containers? So we go for containers because containers are portable, lightweight, lightweight and runs faster. These are the reasons why we go for containers. Then in Docker, how do we make containers? How do we make containers? This is very important. How do we make containers? How do we make containers? To make your containers, let's say making a container is nothing but running your mini server, running a mini server with our application. Container is nothing but this is also a machine, like how we run EC2 instances or how we run virtual machines. Same way, you run a lightweight virtual machine with your application. That is nothing but a container. Container is like building our house. So now, before building a house, you should plan for your house. Am I correct? You should plan, you should
Yes.
build some blueprint,
Yes.
right? So that blueprint is nothing but image. Thus blueprint is nothing but image. So this image is nothing but container image, or we'll call it as Docker image. So what is this Docker image? Docker image is nothing but blueprint to create the container. So this is the blueprint. So Docker image, it's a blueprint. So blueprint for container, this is the blueprint. Now first you give your requirement. What you do, you will give your requirement. So you can't build, you can't create a blueprint without requirement. First you will give a requirement. Being a customer, you are the customer. Now I'm an engineer. If you give your requirement, I can build a brief, I can create a blueprint and I can give you, right? Same way, there is something called Docker file. So we write something called Docker file. Docker file, it's a file, it's a text file where we write instructions. So where you write instructions to create Docker image. So using Docker file, we create Docker image. So from Docker image, we create Docker container. This is how this procedure works. So you can't directly create a Docker container. For Docker container, you should have Docker image. So image is nothing but a blueprint to create a Docker container. Docker container. So this is our application. Now app is running. This is
So
our
you mean inside the container, our application and images, all those resources will be there.
You're right. So now our application is running as a container. Inside the container, my application is running. This is a kind of mini server now. A small server, a lightweight server. Then why do we call this as a lightweight? Why it is portable, how it is lightweight? To understand this, we have to understand the Docker architecture. Right? So already you would have some idea about Docker architecture, but let me brief out Docker architecture. So how Docker works, to understand that you have to understand the Docker architecture. So let me show you here. You see, in Docker, majorly there are three components. So Docker client, Docker host, and Docker registry. So this is Docker CLI. This is Docker client, where from where you run Docker commands. So Docker client, and you have Docker host, from where you run containers. This is where you run Docker containers, Docker host. Then you have something called Docker registry, nothing but our Docker hub. So Docker registry, nothing but our Docker hub. So now
So host and client is both are servers, right?
host and client both comes in server. These comes
Okay.
together, these two parts, right?
Okay.
It's just a tool. Docker client, it's just a tool where you can communicate with the Docker host. Now in this Docker host, you have your containers, you have your volume, network, and everything. So let me show you. So here there will be a background process that is nothing but your Docker daemon. So here we have Docker. So Docker daemon. So this Docker daemon is a background process. So whatever it's like in our Kubernetes, we had Kubernetes API, right? Like which was the main controller, main door. So this is the main door for everything. So whatever the command you run, Docker PS, Docker logs, all the commands will be processed from here. So now let's say I want to run a container. I want to run a container for my Python application. So my Python application image. So Python image, Py app. So Py app, it's an image. It's a my Py app image is already there in Docker Hub. So Docker Hub, what is this Docker Hub or Docker registry? I hope you already have an idea about this.
Yes.
Yeah, so this Docker Hub, it's like a GitHub for Docker images. It's like GitHub for Docker images. I hope, Tapan, are you understanding? Are you getting the idea?
Yes,
Since
yes, yes.
yeah, since already you have an idea, Kritika, are you getting?
Yeah, actually, how is it related to the GitHub repository?
No, in GitHub repository we host the source code, but in Docker registry we host the images. So in GitHub we host the source code. In Docker
Mm-hmm.
registry in Docker Hub we just host the images, Docker images. It is a place where we save or where we store and manage the Docker images.
Like GitHub is the place where we store the code, and here we can store the images. Is it
You're
like
right.
that?
You're right. You're right. So now this image is there in Docker Hub. If you want to run a container, this image is a blueprint to run a container. If you want to run a container, first you should pull this image. How can you pull this image? For this, you have a command docker pull. So you will run this command. So this docker pull command, this requests the Docker daemon. The request will be sent to Docker daemon. Then Docker daemon will go to Docker Hub and it goes to the Docker registry and it pulls the image to your local machine. So
So Docker daemon will handle everything. That means.
yes, you're right.
Okay. Okay.
Yeah. So let me delete few things here. Storage is full.
But I have one doubt. Like, why do we use Docker instead of manually? Also, we can install software inside the container, right?
How do you install software manually inside the container? It's not possible.
Oh, okay.
So how do you manually install? We want to make our application portable, easy to distribute. That is what the reason why we make it as a Docker images.
Okay.
Yeah. So so image is pulled. So now this image is just a blueprint. So now image was there in GitHub or sorry, Docker registry, Docker Hub. then you pull the image into your local machine. This is just an image now. It is just an image. It's not running live. So now how can you create container out of it? If you want to create a container out of it, so you have to run another command called docker run. Docker run, then you will mention the image name. So using this image which you pulled it, so it creates a new container. So it will go here, the request will go here, then the request, this will take the image and it creates the container. Are you understanding the flow?
Yes.
So first I pulled the image, then using that image I created the container. Now this container is running my application. So my app is running inside this container. Like this I can create hundreds of containers. So in real time, let's say you are a microservice application. In your microservice application, let's say your microservice application is Flipkart. Okay, so your microservice application is Flipkart. In Flipkart you have different services. So you have authentication service where user authentication is taken care. You have cart service, you have order service, you have checkout service, then you have ad service. So there are different services, means different applications. This is a different application, cart is a different application, order is a different application, this checkout is a different application, ad is a different application. So everything we are managing as a small different applications, because managing this application, this big source code, will be easy when you manage it as a small chunks. So now I divided one application, the Flipkart. Yeah, so I divided this Flipkart as a small pieces. So now this auth application is developed by somebody and managed by different team. Cart can be managed different team, order is managed different team, and they are scaled, they are deployed, they are containerized separately, and they are managed separately. So they communicate through APIs each other. So I can deploy. So now I'll deploy all of these services as a containers. Auth separately, cart separately, order separately, checkout separately, like that. I deploy everything as a separate containers.
That's what I was going to ask you. Each one is a separate container.
You're right. You're right.
I think I was about to say that. So each one is a separate container that we build, and then we build all the containers. And okay, I got you 100%. Thank you. I was about to ask, and then you said it. Thank you.
So all of these are different containers, and it is managed differently. So I have a small project in my GitHub. Let me show you to give a brief understanding about how things work. I think yeah, I hope you can see this. Is my screen visible? Yeah, so this is a small microservice application. It is a free application by Google. See, this is our application. See, front end is that, checkout service, recommendation, ad, product catalog, cart, shipping, currency, payment, email. So this is one application but different microservices. Can you see this? Hold on. Yeah, so this is the architecture of the application. So we have an application. For application we have front end separately, checkout, payment, email, currency, shipping, cart, product catalog, recommendation, ad, and everything separately is there. Are you understanding?
Dayanand, I have one question. This is Tapan here. Can I go ahead and ask?
Yeah, please go ahead.
Yeah, suppose let's say you are saying we have to create different microservices, right?
Yeah.
So in that case, so do we need to create separate image also?
Yes, you have to create separate images, separate Docker file for every
That means while we are pulling the images, we have to run the separate Docker hyphen pull that command you said, right?
You're right.
To create the image. Okay.
So is it like for all each resources or each services we have to create an image?
Yes, you're right. So now I'm going to
Yeah.
show you. You can see this is the source code. So you have source code. In this source code, separate folders are there. This is the folder where source code is there for add service. This is the folder where card service is there, checkout, and different, all of that in different folders. Let me open add service. Add service is one of the feature, one microservice. So in this, you can see it is a Java project. So they have used Java to write. So it is a Java source code. Let me show you source code first. You can see Java. It's a Java. They have developed this add service using Java. So you can see Java code. So they have written Java, right? So this they will write, developers will write. So now in this, I have a Docker file. Can you see this Docker file? If I open the Docker file, this Docker file is packing this only add service. So only with service, add service. For this, we have this Docker file. So this is a Docker file. This packs this add service. Like this for everything. For cart, yes, for cart also I have a Docker file. Cart, I guess they have used .NET. You can see this is a .NET application. Let me show you. So they have used .NET. Yeah, services. If you open program.cs, cs.json, let me open Docker file. In Docker file itself, I will get to know which image they have used. Microsoft.NET. Can you see this? So it is a .NET application. They have used .NET. So since it is a microservice project, you will get to see all. So maybe this checkout is Python. Let me check. Checkout service. If I open, it's a Go. This checkout is developed using Golang. Then if I open email service, this email service is developed using some other language. Let me see, I think Python it is. Python. Can you see this? So one application, there are 5 languages: Java, Python, C also involved, I guess it's C also there, .NET, then Node is also there. Let me show you Node as well. Node,
It's
JavaScript.
not mandate to use only one language, right? We can use multiple language for the multiple resources or services.
Yes, you're right. It depends on their application architecture and the tech stack that they have chosen. Yes, you are allowed to use any language which you want, but you will not be involved as a DevOps engineer. Developers, whatever their language they want, whatever the tech stack is decided while developing the product, while designing the architecture, so they'll use it. So according to that, we have to build the Docker files. So now Docker files, is it developed by a DevOps engineer or a developer? It's both possibilities are there. So they can only develop Docker image. They can write the Docker image and they can give you the image, or else they'll give you the source code. You have to write the Docker file. Then now question will come: how can I understand and how can I write Docker file? To write the Docker file, first you have to understand this project. So you have to understand if it is a Java project, if it is a Gradle using Java and Gradle, how can I write Docker file Gradle? And what commands are needed to execute this project? How can I spin up the application? So if you go inside this, you can see this is the image that they have chosen, Eclipse, and this is the image. And it's a multi-stage image actually. If you don't know what is multi-stage, maybe in next session we'll discuss about Docker multi-stage images. So in the first one, they're copying all the Gradle files and they're downloading all the dependencies. Gradle download repos. This will download all the dependencies needed to run this application. Then in the second step, they're spinning up our application Java, and this is running on port number 9555. So like this you can write your Docker files. So by looking into different Docker files, you will be able to write it. Docker file is not that difficult. If you just see that any Docker file, if you open, it's not that difficult. So just you will select the image, then you will select the working directory, copy, then run, then you're good to go for this. You should know how can I spin up this application, how to run this application. How do you get to know this? So when you're closely working with dev team you will slowly get to understand how can I run Java application, how can I run .NET application, how can I run Golang application, how can I run Python application. That is why running an application on a server, you should have an idea how can I run this application on server, because if you know how to run an application on server, then same commands you can put it in your Docker file, so you'll be able to pack your application. I hope you're getting some basic idea about it. Any doubts here? Any questions?
Yeah, all good.
Yeah.
Got it. Yeah.
Yes. So now these are the different images for the same application. What I do, so I will build images using this Docker files. So I will build images using Docker build. Either I can push it into my Docker Hub if we are using Docker Hub as a official repository within our organization, or if we have our own private repositories, like in AWS we have ECR, Elastic Container Registry, or we have JFrog. You can use JFrog repositories, or any repository, any private repository where you can host the images that are, you can use any repository. You will push that repository, you will push this images to repository. Later in Kubernetes, same images will be pulled and we run as a parts. I hope you're understanding this.
Any VCS tool we can use, like I mean, GitHub, GitLab also we can push it to there, right? I mean, to that repository as well, right?
Yes, yes. If we,
Okay.
yeah, so you can push it wherever you want, wherever images can be
Mm-hmm.
stored. Yes, you can push the images and you can store it.
Mm-hmm.
Usually in companies, they may prefer JFrog, or they may prefer, if they are using, if your company is using AWS resources, they may prefer ECR, Elastic Container Registries. If a company is using Azure, then they may prefer Azure Container Registries. Or if you have your own setup everything, then you can just go for JFrog, installing and managing everything by within your organization. So anything is fine. You can push image wherever you want, or else Docker Hub also fine. So you can push your images into Docker Hub, and you can pull directly from Docker Hub. And in Docker Hub already there are images. There are free images which you can download and we can use it for free of cost. So let me just show you the Docker Hub. So if you go to browser and just type Docker Hub, yeah, so this is the Docker Hub. So in Docker Hub, so already we have images, pre-built images are there. So we can just go here and search for the images. Let me search for an image. Let's say I want to spin up a database. So MySQL database, I can just search MySQL. You will get the image. You can see MySQL, this verified. Let me open this. So you can see MySQL. This is the image of MySQL, a Docker image. You can directly spin up this image. You can create a container of MySQL. So if you want to create MySQL in your servers, first you have to spin up a server. Then you install MySQL server on your EC2 instance or VM. Yeah, so EC2 instance or VM, and then your uh, database will be ready. But here it is very simple. Let's say I want to spin up any version of MySQL. I will search for the version. These are all the versions tags. So 8.0 Debian, Bookworm, Oracle Linux, Oracle. So you can spin up on anything. Let's say I will go with this latest LTS. So our latest one. So let me go with latest one. So if I click on this latest, this is the Docker image. Let me click on this.
So
Yes.
how we will authenticate like which image we have to take or which if we have to
I
give
was
in the
about to
latest
ask
or
that.
version detail. So if you are giving version detail also, like how will I confirm this?
See,
Incredible me, please, yeah, please, Gauda. I guess the developer will tell us, or
um, yes. So in the README file of every project, let me show you here. So developers should tell you, and they'll give you the README file. I guess in this there should be a README file. Let me check. Since it is a demo project, I guess there is no readme file for this service. Yes, so developer will tell you what image and which image tag we should use, or else let's say I gave you a Java project. So my Java application, I have used Java 17. How can I search Java 17 in Docker Hub? So how can you do that? So for Java, it is OpenJDK. So let me search OpenJDK, OpenJDK. Since you are going as a DevOps engineer, so you will be the one who have to suggest all of this. So let's say OpenJDK. So I will go for OpenJDK, and yes. So this is the OpenJDK official Docker image. So there are many images. You can use anything. So this Circle CI is a different company. Jenkins, they have OpenJDK, and there are many companies, they have their own OpenJDK images. Just I'll go with official Docker managed OpenJDK. So this is managed by Docker, the company, Docker organization. This JDK, how can I select 17 JDK 17 here? So you click on this tags. So click on the tags and um, search for version. Let's say I want 17. I'll search for 17 JDK. Then I'll enter. Yes, I'm not getting here. Let me search for JDK 17, JDK hyphen 17. Yeah, so JDK 27 EA, I think. Yeah, so it is 17 JDK, 17 hyphen JDK. Yeah. Yes, this is the 17 version. So you can see here 17 JDK, 17 JDK Slim, Bookworm. So these are the different operating systems. So Slim, Bookworm, this is a Bookworm, 17 JDK Windows Server. You can choose
What I
whichever you.
understood is like this Docker, like if image is already available in the Docker hub, then we need to pull the image
Yes, you can directly
to
pull the
create a con.
image. Only official images are preferred. You see, even this image is there are four high severity vulnerabilities and zero
Yeah.
critical. There are medium five severity. You have to check with your organization that is it okay that if I can use this image with four high severities. You have to check with your team, right? Or they may prefer to use some dedicated operating systems if they have, or they may prefer to, you know, you're not you're not authorized to replace. Okay, so fine. So they may prefer, or they may choose their own images, if maybe enterprise
So all
version.
this detail will be given by the developer or the team, right? If we
So
can use our image or we have to pull the image.
yes, that
And one more
information.
thing I wanted to know, like if I have, suppose if I have source code, I have Docker file, and I have requirement file also, then I can create my container easily.
Yes, you're right. So you
Okay.
can create your container easily. First, you should have a better understanding of your product, your project, your source code, what tech stack you have used, the architecture. So when you have a better understanding, you will get a better idea of which image is best. So you will be in a position where you have to suggest. If you're in a senior position, then they'll ask you what to suggest, and you have to choose. So you have to choose an image with less vulnerabilities and official images. So if you search OpenJDK, there were 100 images. So I chose Docker official, and you can choose official images like from organization like Jenkins, Circle CI, or such organization you can choose. Let me click on this. So let me search here. Let's say I want Python now. So how can I use Python? So if I write Python and enter, so you will get Python images. Yeah, so you can see this is the Python image. So Python by DHI. So I'll go with official Docker official image, or Python for Azure functions, or Circle CI Python. This is an organization, Circle CI, or Bitnami Python. Bitnami is an organization. You get Bitnami, or Ubuntu Python. Ubuntu Python is there, or you can go Intel Python, or any of this you can know, whichever you feel you feel comfortable, or whichever you feel that is okay for my project. Yes, you can go with this. Since anything, this is also fine, this is also fine, this is also fine, and this is also fine, all are
Identify
Bitnami is also
one we
fine.
have to take.
Sorry.
How we will get to know, or how we will suggest, like if I have to suggest my team, like okay, this image we have to take.
let's
How
say
to?
let's say if somebody asks me which Python image shall I use, I will give four options to them. You see, we have a Python image by Docker official Docker organization, and we have a Python image by Bitnami, which is VMware product. It is by VMware, and we have a Python image by Circle CI, and we have a Python image by different companies. Like you see, Intel Corporation, it is one company. They have their own Python image, and they have
Choosing image will not impact my containers, right?
yeah, it will not enter. It is just a basic container, base image.
Okay, 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 okay.
Base image, only Python will be there. On top of it, you have to add your application.
Got it, got it.
Yeah. So now base image. So I will get this base image. Let's say I will use this Python image. So official Docker image, Python 1. So I will check with this. I'll go with this. Then I click on tags. Let's say I want Python 3.9. I will search 3.9. Python 3.9. Yeah, so Python 3.9, 3.9, 13.9, 3.9.5 or something like that. Yeah, see, 3.9.5. Okay, so I can use this 3.9.5 slim. So I'll go with this. And here also there are four high severity vulnerabilities. It's fine if you want, if you're comfortable, you can use it. Not a
Can
problem.
you please explain this, like vulnerabilities and this high severity, and what does it impact? Like this
Uh,
part, I don't understand.
yeah, so let me go for I guess anybody worked in the coding part, I guess. Tapan, have you worked on any coding related things? Could you go with this vulnerabilities, how you uh, understand about it?
No, coding
Yeah,
has never worked.
yeah, I have worked it actually. I like to explain what vulnerabilities is.
Yeah.
So there are actually like three types of major vulnerabilities that you say. So if you are leaving some secrets in your code, then that's a secret type of scan that you are like doing. Then there's another vulnerability which is like dependencies. So dependencies is based upon like if there's a backend front end that's happening, right? And if the APIs are returning some kind of content to the backend engine. So if there's direct errors which you're fetching from the engine, like your application, and then you're returning directly to the front end, right? It's just showing your backend error directly in the console with the front end console. Then that kind of vulnerabilities are like code dependency vulnerabilities. Then we have code scanning for that also. Like code scanning is like if you are printing some kind of statements like print statements, something like that inside the backend log. So those types of vulnerabilities. So basically the more vulnerability or critical vulnerability, I would say, if you're returning any kind of error from the backend engine to the front end part of it, and if you're leaving any kind of secrets directly in the code. So those kind of vulnerabilities are basically present. And I'm
Okay.
thinking in the Python mostly it's that's what happening right now. The vulnerability that it's showing, right?
Hmm.
Though yeah, the open-ended images which have like issues right there. So I'm thinking that those things are already being added up properly.
Yeah. Now, Atul, are you understanding this?
Yeah, I got some point actually. Yeah.
Okay. So if you want me to simplify in a very simple way, so these vulnerabilities are nothing but um, you are disclosing some sensitive data of your application or something like that. Let's say um, you have some source code. In your source code you have kept some secrets or some keys, API keys, or username, passwords. When you execute your application, if somebody get access to your server or your machine, since you have included your keys or your username, password, they will be able to see that. This is one kind of vulnerability, or we'll also call it code smell. Code smells will be there where you should not leak any data or any ways for attackers or somebody who wants to steal the data, or somebody is trying to hack your machine, or they are trying to attack it. They should not get any door, or you should not leave any door for them to crack your machine or crack your system. In that way, that is what we 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 call this as vulnerabilities,
Okay. Okay.
right? So the more vulnerabilities, that means your code, the image is not secure. So you have to go with less vulnerabilities, means your image is more secure. So here critical, I mean, there are zero critical, so there are some high severity. So you can just go with this, and you always have to choose an image with less vulnerabilities. So these are all analyzed by Docker Scout. There is a tool called Docker Scout in Docker Hub. You can use with that. So this is about, just I wanted to give an idea what is container so that we can get started with Kubernetes. Now, if you don't have any, it means you got a understanding about containers, then I'll switch to Kubernetes. Is that fine?
Yes.
Yeah. So now Docker is running fine. My application is running fine with Docker. Then why do I want Kubernetes? What is the purpose of Kubernetes? See, if let's say I'm running a container of a cart container is running, but at the same time I'm getting lakhs of requests on my application. Maybe lakhs of customers are doing shopping in Flipkart. So, do you think this one single container would be able to manage everything? Do you think one single container would be able to manage 1 million users or half a
Nah,
million users?
you would need multiple containers.
Yeah, so you will need multiple containers. How do you create multiple containers? How do you manage multiple containers? So in real time, there will be hundreds of microservices for one single application. All 100 microservices will be running in thousands of containers. So let's say you have thousands of containers running together. How do you manage all these containers? How do you create, delete, update, patch? How do you do all of this stuff? It's very difficult, highly difficult. If one container is not running, a container is crashing, or it is in pending state, or if it is not serving the traffic, it is very difficult, highly difficult for you to handle containers in the large scale. That is where Kubernetes comes into picture. So now this Kubernetes, it's a container orchestration tool. It automates the container lifecycle. So if you already used Kubernetes, so some of you have idea about Kubernetes, you have worked on Kubernetes, you know Kubernetes architecture, right? So there will be different servers working together to run our application. In the servers, you have hundreds of containers running together, not hundred, thousands of containers running together, right? So now let me ask you, like, how many of you have worked on Kubernetes? So I know that Atul, you have worked on it, and Mariano, you have been working on Kubernetes from last couple of years. And Tapan, do you have any idea on Kubernetes? Have you ever worked on it?
No, Kubernetes, I did not get a chance to work.
Yeah. So Abhishek, do you have any idea about Kubernetes? No idea. Okay. Okay. Kritika, do you have any idea about Kubernetes?
No, I don't have any idea.
Okay. Then let me just brief out you how Kubernetes works. So now
Oh,
you
Stephen, I just learned what you like taught us in the last class. That's that.
So now, yeah, you have a basic understanding now how Kubernetes works.
Yeah, exactly.
Yes, you're right. You're right. So now, let me um, tell you again what is Kubernetes. Kubernetes, you can just assume it as a hotel manager. So there is a hotel. In hotel, we have chef, we have customers coming, we have waiters, we have all the workers who are working our restaurant, right? So now Kubernetes is a restaurant, you can say. Yeah, so it manages everything. Customers are coming, waiters are serving, chef is cooking. So now Kubernetes, it automates the container lifecycle. It creates the containers on demand. It deletes the containers. It updates the containers. It restarts the containers, and it does all the tasks for containers. So you don't need to worry. Like I said, when you are managing large number of containers in a very big scale, it is highly difficult to manage it. But Kubernetes makes it very easy uh, to automate this task. So how Kubernetes works? So internally, Kubernetes, it works in cluster. So first we have to understand Kubernetes cluster. In last session, I guess we discussed about the cluster. So let me quickly show you. Somewhere here I have written. Docker, Kubernetes. Yeah, I guess. Yeah, so this is where we discussed in the last session. So in the last session, as we discussed, so Kubernetes, in Kubernetes cluster, majorly we have two components: control plane, where I was writing now, I lost. Where I was writing here. Okay, let me take somewhere here itself. So how this Kubernetes works? So very simple. If you want to understand Kubernetes, um, so you all have an idea about servers. I guess you have an idea about servers.
Yeah, I have.
Yeah, you have idea about servers. Now our containers runs on servers. So we need computing devices to run our containers. So our containers runs on machines. These are the servers. Let's say this is a server 1, and this is server 2, this is server 3. If you are from AWS or virtual Azure, but Azure, then you can assume this as EC2 instances and virtual machines. So these are server 3. Now these servers have some capacity, let's say some RAM, some storage, and some computing capacity is there. Now our containers containers runs on this servers. These servers are called as nodes. These servers are called as nodes. This is node 3, let's say node 3, and node 1, node 2. So node 4. So my board is full. Let me delete some of the content. Yeah. So now this is a node. So in this node, I am running a pod. So sorry, this is a container. Let's say a container is running here. So and another container is running here, and another container is running here. Maybe another container is running here. Another container is running here. Like this, we are running multiple containers. So these are the containers. So now this is a container. Let's say this is a container. This is an auth container. auth container. It's running my auth, and this is a container of, let's say this is container of order, and let's say this is again auth container. Let's say this is again auth container, and this is again order. So ORDER. This is again order container. Let's say, and let's say this is again add service, add or cart. Let's say cart service, cart container. So cart container, and maybe let's say this is also a cart container. So like this, randomly containers will be running in different nodes. Well, let's say this is also an order container. So this is how containers runs. So these containers will be wrapped as a pods, like you are keeping your lunch in your lunch box. So now Kubernetes does not understand containers. Kubernetes understands something called pod. So now this is a pod. Pod is nothing but just a wrapper around your container. Now this is a pod. So this is a pod. This is a pod. So I'm keeping my containers inside a wrapper. So this wrapper is nothing but a pod. Are you understanding?
So there will be the different containers for each service.
Yes, for each service there will be different containers, and each container will be wrapped as a pod. Now it's
Okay.
no more a container, it's a pod. So inside a
So it
pod,
will
what is
called as
running?
a pod, not a container.
Yes, so in a pod,
Okay.
so inside a pod, container is running, but we will refer it as a pod. So you don't need to worry inside what is running and all, just it is a pod. So pod, inside a pod we are running a container. Usually we run one container in one pod, one container per pod, so that if this pod is not running, that means this auth service, auth container is not running. Just like you are wrapping it using a cover, that's it, using a bag. Now this is a pod, this is the pod, and this is the pod. Let's say this authentication, this is an application, authentication application, it's a microservice. This microservice wants to communicate with this cart service, or this order service wants to communicate with some other service. Let's say it wants to communicate with auth service. How do we schedule, how do we create pods inside this nodes? How do we create pods in this nodes? And how do we create, or how do we delete all of these pods? Who will decide all of this? To decide all of this, we have another machine, another EC2 instance or a virtual machine. This is nothing but control plane. This is very important. So control plane. What is this control plane? Control plane is nothing but a driving seat of a bus, kind of, you can say. So now this is a control plane. This control plane, it is an EC2 instance or a virtual machine, you can assume it as. So it is a server. This is a main server. In this main server, there are different components. You have something called Kube API server. You have Kube API server. So this Kube API server, it's a front door. It's a main API for Kubernetes. All the communication happens in this cluster. Whatever the communication happens in this cluster happens to Kube API server. Okay, so Kube API server, all the Kubernetes command, whatever the Kubernetes command we run, kubectl apply, kubectl delete, describe, whatever the Kubernetes commands. In Docker we have Docker daemon, right? Similar way here we have Kube API server. This is the main API. It's a front door for our Kubernetes. All the commands or whatever the request you do through Kube API server. Next, when you run a kubectl apply, or when you are requesting to create a pod, So you will send a request to Kube API server through a Kubernetes command. Then Kube API server will receive your request, and there is a component called scheduler. There is a component called scheduler. This is a component which decides where to schedule a pod. So you are not specifying where to create a pod. So I could have hundreds of nodes, I could have hundreds of servers working together. This scheduler will decide, should I schedule, where to schedule this cart pod, where to schedule this order pod, where to schedule this auth pod, where to schedule order pod. Like that, it decides. How this
So is it
decides?
scheduler will decide where to create a pod, or we can also decide?
Scheduler will decide automatically where to schedule a pod. If you want to schedule a pod on a specific node, you can do node affinity. You
Okay.
can,
Oh, yeah. Oh, yes, 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 yes.
yeah. So if you want a specific node, you can specify tolerance on taints, or you can apply node affinities. So that is a different concept. We'll discuss it later. If you don't have anything on your cluster, it chooses based on the resource availability, based on the server capacity, based on the availability of your node. It decides where to create this pod. Then how it decides, how it will get the cluster data, on which node how many containers are running, what is the resource utilization and all. There is something called etcd or etcd. This is a component which stores all the cluster data. So which stores all the cluster data, in which cluster, what, in which node what pod is running, and what is the resource utilization. All the cluster related data will be stored here. It's like a memory, human brain. We have brain, right? So this HCD is a brain here in control plane. It remembers everything. So which node, how many nodes are there, how many parts are there, where what running, and everything remembers here. So scheduler, so you will send a request to Kube API server. So scheduler will schedule it. So data is stored in HCD. Then you have something called controller manager. Controller manager. This is a guy, he is like a doctor. Okay, so this guy will make sure the desired number of containers are running, sorry, the pods are running. If any pod is not running, it will restart. This controller manager, this manager will restart the pod, or this manager will restart the pod in the old pod, in the place of old pod. It's like a doctor here, he's like a doctor here, right? So now all is working together. This control plane, it's like a manager, hotel manager, so who manages everybody. So there are different nodes means the servers. This control pin is also a server. Now this control API Kube API, it's a main door. Now this communicates with everything. So HCD is connected to your Kube API server, scheduler is connected to your Kube API server, and controller manager is connected to Kube API server, and your Kube API server will be connected to node through kubelet. So there is something called kubelet. So what is this kubelet? Kubelets, it's an agent which runs on every node. So it's a manager for node. So we have different nodes, right? For each and every node, there is one manager. There will be a manager. That is nothing but kubelet. So this kubelet, it is a manager for all the nodes. So here we have different kubelets. So now all these kubelets will be connected to our Kube API server. This kubelets will be connected to this Kube API server. And here how pods communicate to each other. Like one pod would like to connect to another pod. Like your backend wants, let's say cart. So for cart, there is some logic which is running. This whatever user is adding to cart, we should store it in a database. For database, we will be running another pod, DB pod. Let's say you have a database, MySQL. So now whatever they are putting in cart, you have to store it in a database. I'm running a MySQL pod. So now this cart should communicate to MySQL. How this communication happens? For this, we have something called kube proxy. It's a network. It enables the communication between the pods. Kube proxy. So this kube proxy runs on every node machine. So if you want to increase the node number, yes, you can add multiple nodes. So here I have 3 nodes. These are all workers. So if you want to add, you can add more nodes. So this is how your complete Kubernetes cluster works. So here we have Mariano, who he has multiple years of experience in managing these Kubernetes clusters and all these components. So I would like to hear some words from him. Yeah, I hope I'm audible. Mariana, are you there?
I sure am.
Yeah. So yeah. So now you have been working on this cluster, right? So anything that we missed about the cluster?
No, I love how you explained the architecture of the clusters. You know, not the everyday things that we do. I'm sure we'll get to that, and that's like what I do every day. But this is, you know, with the etcd, it's the database, the Kube API server, the scheduler tells you know where to put each pod, the control manager, how kubelet runs on every node. um how about for networking, how they talk to each other? There's something else, if I'm not mistaken. Are we
Kube
missing
proxy.
something? That's a Q proxy. That's it's a networking inside. Okay.
Yeah.
Yeah, and then we'll get to like you know the services and all that later of how you know they all talk. But this is great.
Yes. Yes. So now, if you're managing your own Kubernetes cluster, then you have to manage the control plane as well, and you have to manage the nodes as well separately. So managing the Kubernetes cluster, it really sucks because you have to take care of etcd, API server, scheduler, control manager, the control plane. If control plane goes down, our complete Kubernetes cluster will go down. If any node goes down, again all the pods in this node will go down. I hope you're understanding this relationship. So
And
that,
Node
Can you
yeah,
please
usually
repeat it
goes
again?
down with multiple reasons.
yeah, so node
You
can
know
go
what?
down. Yeah.
Can I add something to that? I love what he said, because if you're working on EKS, like on AWS, they control the control plane. They patch it for you. I work on VMware. There's different flavors of Kubernetes, but they all, at the end of the day, do the same thing. You know, you reach the customer doesn't really know if you're using AWS. The abstraction should be transparent to the customer. I love what he said. Uh, I have to patch my own control planes. And I've had issues where I had to call support because when the etcd database gets corrupted, forget it. It's I would much rather use EKS, but in my case, I have to use, you know, what I use. But for the most part, in if you're using EKS or AKS in Azure, they control that for you. I don't have that luxury.
Yeah. So, yeah, that's where it gets difficult. That is where Kubernetes becomes very complex to the company, for the company or for the customers who are new to Kubernetes. It's really gets very difficult to manage this control plane. So there are services as you mentioned EKS, Elastic Kubernetes Service by AWS, and we have AKS, Azure Kubernetes Service by Azure, and we have uh, GKE, Google Kubernetes Engine by Google. So there are many. There are SAP related cloud. There are SAP related clusters. There are Oracle Kubernetes clusters. There are Alibaba Cloud Kubernetes cluster. There are many Kubernetes clusters available in the market.
So
wherein
it's like they manage all these things, right?
uh, yes, I mean, it depends
Like
on
we have how I am working in SAP Cloud, so even I got confused. Like who manage these things?
control plane is not managed by us because we are using managed cloud. We
Okay,
have only
okay,
access to this nodes. So
okay,
since
okay,
if we are using managed Kubernetes clusters like EKS, GKE, or any other cloud managed Kubernetes clusters, this control plane, you don't have any control on the control plane. Updating, patching, managing, and doing all the stuffs related to control plane is done by the cloud provider itself. You no need to worry about setting up the control plane, dealing with the control plane components, nothing. Everything is abstracted. You don't have control over that. And that is where it simplifies the Kubernetes, right?
okay, okay.
Yeah. So, and I would like to ask a question to Ariano. Don't you have backup for this control plane? Do you run only one control plane for cluster?
Very good question. Our standard is 3 control planes, and then we start off with 3 worker nodes. But sometimes during upgrades, because we do our own upgrades, see, that's where the problem comes in. During patching, that's where things get a little bit ugly. When we upgrade control plane, what it does, it'll drain the node, but sometimes there have been issues where we've had issues. When you work in EKS, AWS patches the control plane for you, and you only do the worker nodes. The worker nodes are easier because it's your application, it drains it, and your application's always up. So that's a very good question, and 99% of the time it goes good. But I've had a few instances where we've had when I go in and I start patching. For example, when I say patching is, for example, upgrading. Right now, we're upgrading to version 1.33 from 1.32.
Okay.
So, when we upgrade the control planes, those get upgraded first. Sometimes they get stuck, and you don't know. You go in, and then I've had an issue with, again, with the etcd became corrupted, and it's like, oh man, and working with VMware support to get it up and running, and that's beyond the scope of a. I don't know. What's your feel on that, Gabra? I think that's beyond a Kubernetes administrator how to fix the etcd database. That
I
becomes
think
so
then and I
complex.
can like relate here. Like, even I upgraded my cluster and I am getting issues now.
I tell
I
you,
can relate here.
without support, I couldn't do it. They go in, they run these special, because Kubernetes is Kubernetes, but every again, like I said earlier, the abstraction, meaning when we give the cluster to the customer, they shouldn't know if it's, you know, EKS or AKS or, whatever flavor, like, Rancher. There's so many different ones out there, like Gauda says. They just need to deploy, kubectl deploy, how many replicas they want, how many, and Gauda's going to get to that. And everyone has a etcd, but I feel like in our instance, in our scenario, being that we have to patch it ourselves, we come across issues sometimes. Like put it to you like this: I get scared every time I have to patch, every time I have to upgrade.
Yeah, even I am like facing. I just upgraded my dev cluster, and after upgrading, I'm getting this network error issue.
You see,
Yeah, and one thing that we have to be very careful that whenever we update a Kubernetes cluster, we have to update our applications as well. So let's say you're running some old versions of Kubernetes, your application is not compatible to that Kubernetes version. The image, the Docker image which you are using, which is not compatible, over the period of time, the image is you have to change the cluster as well. You have to update the applications as well. So that is where most companies we lack. What do we do? So rarely we update once in a year or once in a couple of years we update. So now currently, I think latest Kubernetes version is, I don't know exactly, but the 1.2 and 1.3, these are very old Kubernetes versions.
Yes.
Yeah, so that's where it really gets very tricky. So Kubernetes, they'll stop supporting this old versions going forward. So we have to make sure that we are running latest Kubernetes version, maybe as much as possible.
Okay.
But what is the role of EKS here? I didn't get this one.
So now, instead of creating control plane and EC2 instances and all separately, if you want to create it, you have to go to AWS and create 4 servers and install control plane components in one EC2 instance and install all the node, I mean kubelet, kubeproxy and everything in other EC2 instances and connects them together. This is all manual task. Instead of doing this, so you just go to EKS and you just say, I want this many nodes. With this capacity, your node is ready. You don't need to do any installation of kubelet, kubeproxy, etcd, kubeAPI server, scheduler, control manager. No installation, no configuration, no need to connect any nodes, nothing. Everything is ready. You are ready to go. So like how did we do RDS? Same way. You don't need to set up anything. You don't need to configure anything. You don't need to patch anything. Everything is ready. You just focus on building your product.
Okay.
Yeah. So Abhishek, I hope you're understanding. And Tapan.
Yes, I'm clear. Clear.
Yeah. Yeah. So now let's get into the communication. How the traffic enters our cluster, right? So here I told you that to understand this, let me take it right side. I just want to copy this. Let me copy this into right side. So what I'm gonna do here. So let's discuss how traffic enters to cluster. So how do we manage the traffic? How somebody, let's say,
Oh, hold on. I gotta say this. This is my favorite part. Guys, pay attention. This guy knows. I'm sorry. I get excited.
yeah,
This is my brother Gouda. How traffic enters. I'm sorry. I get excited. I make it fun.
yeah,
And and my brother here knows his stuff. Pay attention here. I know I'm crazy. My wife is yelling at me. They're gonna think you're crazy. I am crazy. Go ahead, brother
yeah,
Gouda.
yeah, yeah. So yeah, because it is very interesting and very important part of the cluster. So that's where we have to pay a little bit attention here. How the communication happen between the cluster, between the nodes. I mean, parts will be running in different nodes. So we have to understand this as well. The communication is very important. So let me tell you here, we have 3 nodes. Let's say I have 3 nodes. My cluster is running smooth. This is node 1. Let's say node 1. So I would just color it in different color. This is node 1. This is node 2, and this is node 3. Because anyhow, we are running our application here. The traffic should come here. I mean, we have to redirect the traffic to this parts. This is my application is running. This is why the logic is running. How traffic is entering my cluster, how the just I'll remove this kubelet and kubeproxy and all of this stuffs. So I just hide all of this stuff. You just know already that kubelet will be there, kubeproxy will be there on the servers. Just I'll remove these components. Just we will play with pods. Now there are pods and control plane is abstracted now. You already know control plane is there, but I'm not showing the control plane. Let's say how the traffic enters to Kubernetes cluster. Uh, Now, before understanding how the traffic enters to cluster, we have to understand how the communication happens between 2 different microservices. So here, let's say cart service, when you order something, you will order from the cart. So cart should communicate with order service. or whatever you add it in a cart, that should be stored in a database. Maybe you want to communicate with this. How this communication happens, so between the services, this communication happens through services. In Kubernetes, there is a concept called service. There is a concept called service. It's nothing but, let's say you and me, we all are connected. Now our, the connection point is Google Meet. So we all are connected through Google Meet. Now Google Meet is a stable communication gateway for us, stable communication medium for us. So now if Google Meet is not working, we can't communicate. Am I correct? Same way here, service, the Kubernetes service, there is a concept called service, which is supported by kubeproxy. We discussed kubeproxy data previous, right? Yes. So this service, so we created different services for different microservice. Now for cart, I will create something called cart service. Let's say cart service. This is a service, cart service. And there is a service called order service. So let's say ORDER. So order service. And let's say there is a service called MySQL. MySQL service. Now what I'm gonna do, let's say my cart wants to communicate, the cart pod wants to communicate with database, that is MySQL database. So how this communication happens? So cart wants to communicate with MySQL database. MySQL database also running as a pod. How this communication happens here? Here I created a service. It is like a bridge. It's like an intermediate now. So this MySQL service is connected to all MySQL pods. It is connected to all MySQL pods which are running irrespective of nodes. So irrespective of nodes, this MySQL, this is a service. This service has an IP address, a stable IP address, and anybody wants to talk to my MySQL pod, anybody would like to talk to MySQL pod, they should send a request to MySQL service. Now cart pod will send a request to MySQL service. So cart will communicate through MySQL service. It's a bridge. Now this is kind of a load balancer or kind of a proxy. Do you have any idea about proxy? The proxy server, like it's like a broker. Now this MySQL, this is a broker, it's a middleman. Cart pod will send a request to this middleman, the MySQL service. What is this? MySQL service. SERVICE, MySQL service. So this request will be sent to MySQL service, and this MySQL service will send the request to pod, the MySQL pod. It can send to this pod or this pod or this pod. So this is how communication happens. Now let's say somebody wants to talk to cart. There is a cart service. Let's say I want to talk to cart. Now this cart service is connected to all the cart pods. The pods, these are running my cart application. Here I have a cart, and here also I have a cart. So here also I have a cart. Yes. So here also I have a cart. So now anybody would like to talk to cart service. Let's say my order pod. So there is a pod order. So this guy wants to talk to cart. So how this guy will communicate? So this pod will send a request to cart service like this. Now from cart service, the request will go to cart pod. I hope you're understanding the flow. Each and every microservice has a proxy. The proxy is nothing but Kubernetes service. Each and every service, let's say you're running cart, order, whatever, payment, ad service, everything and anything, so which will be running through this card service. Anybody would like to communicate, they'll send the request to this services. From services, this service, it acts as a load balancer by default. It sends the traffic to pod. Easy. Any doubts here? Anybody would like to ask anything here?
Can you explain this flow again?
So now there is a pod, my cart pod. So cart is a microservice. This microservice wants to talk to this guy, the MySQL pod, because cart, whenever somebody put something into cart, they want to store the data to MySQL pod. I mean, we usually store it into database. How cart will communicate with MySQL? That is what I am talking about. So how cart will communicate with MySQL? So pods, they'll not directly communicate with each other. The reason is very simple. Pods can get restarted, because if pod is not working, this pod will be restarted, and pods names are random. There is no unique identity for pods. There is no stable identity for the pods. IP address will change at any time. The pod name will change at any time. So there is no stable identity. This is the reason why we don't allow the pods to communicate with each other directly. So for direct communication between pods is not possible. Instead of allowing the pods to communicate between each other, so we will put a mediator, like a mediator. So this is a mediator. So now this mediator, he is something like a communication bridge. Like now all of us, we have connected through Google Meet. So this is a Google Meet. Now if somebody wants to communicate with me, they can join this meeting, right? Same way, if somebody wants to communicate, somebody wants to insert a data to MySQL, they should send a request to this service, the MySQL service. It's like an intermediate. So okay, hey boss, cart is sending a request. Okay, I'll send the request to this pod, MySQL pod, which is running in the node 1, or I'll send the request to MySQL pod which is running in the node 2. So this is how the communication happens between the microservices. A pod is communicating with another pod, not directly, through some bridge in between. It's like a mediator. I hope you're understanding why do we need mediator, because at any time pod identity will change, the IP can change, the name can change, because Kubernetes will be restarting the pods at any time. This is what the reason why we have this services. So these service, it's a stable network. It's a stable network for communication. Even pod gets restarted, again another pod will be created. Our card service can identify that newly created pod, and it can send the request to newly created pod. Let's say this MySQL pod deleted now. Another 1 minute it will be created again. So again, this is clever enough. This understands through labels, through we have a label concept. So this pod, we can send the request again. I hope you're understanding this concept. Any doubts here?
No. So basically, the MySQL will do the communication, right?
Yes.
With each and every pod.
No, MySQL will not do the communication with other pods. Other pods are doing communication with MySQL.
Okay.
Yeah. So any doubts? Anything would you like to ask?
Yeah, just one doubt then. So regarding that MySQL, whatever the example you gave, right? So it is going to S1, S2, and S3 to the MySQL, right? So it is, I mean, the data will be stored in all the nodes. It's a kind of sync in all the database, or how it is, or it will just copy or insert into one database, or it will fetch from one database.
In terms of databases, it is quite tricky, because here if it is a stateless application, like as you said, because we have three databases, three pods are running in different nodes, data sync, data should be continuous. That what is that? Whatever the data which is there in the first pod, that should be in the second pod. The sync should be there. Yes. So let's say there is one read replica and all are write.
Mhm.
Sorry, there is one write replica and all other pods are read replicas. Okay. So
Okay.
majorly we will write into one pod and the same will be synced into other pods.
But why it's so? I mean, to take the backup of that?
Yes, it could be for backup, and you know that like when you have all the read and write in the same database,
Mhm.
database performance will go down. Am I correct?
Yes, 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 correct.
So what do? We will keep one main database for reading purpose, I mean for writing everything, and we will sync the same data with read replicas. So whatever reading happening, so that happens through read replicas, writing happens through one single uh,
Yeah,
pod.
just kind of execution permission. Yeah, yeah, got it.
Got it. Yeah. So you can do that as well here. So yeah, so that is how it works. But in terms of stateless applications, it's very easy. So in terms of stateless application, you no need to worry about this. So you can send to any pod irrespective because there is no data dependency in this. Like let's say order. So in order, let's say only logic you are running or maybe web servers. So you don't need to worry about it. Now, this is all about internal communication. Okay, forget about this internal communication. Now, how the traffic will enter to our cluster. So very important point. To enter means to allow the traffic, you should have an external IP address. You should have a
Wait,
door.
one second, Gauda. I'm so sorry.
Yeah.
The internal traffic you were talking about,
Mm-hmm.
it all happens automatically. Should we explain that? Like, like the cluster IP, or you want to save that
It happens through cluster IP. So cluster IP.
automatically,
Yes.
right? Okay, and we'll deep that. We'll do one class just for internal networking or an external, because I know what you're going to touch up next, which is the most important part. Which I still to this day, depending on what tool you use, I have a hard time. And once he explains it, I'll tell you a real world example that happened to me last week that took me, and I was sick too. It took me like a week and support couldn't even fix it. It was a weird issue. But go ahead. I know you're going to talk about Ingress and then I'll tell my story so they
Yes.
can understand real world issues.
Yes. So
Sorry
now,
to interrupt my professor.
yes, yes, that's good. That's good. I appreciate that. So we need such real-time scenarios so that others will also understand how they face these issues in the real time. So now here we have this card service. This is a cluster IP which works within the cluster. So this cluster IP will take care of it. Then how internet enters the traffic? Sorry, internet enters our cluster. So for this, we need a door. So the door is nothing but a load balancer or a API gateway. So let's say a load balancer, or I could say an API gateway. So this is a door API. This is a door which allows my traffic to enter this cluster. So this is API gateway or a load balancer. Previously and still now, many companies we are using ingress controller. So ingress load balancers. There is a concept called ingress load balancers. So what it does, it is an entry point for our cluster. Let's say I already said that. Let's say it's an Amazon.com. So Amazon.com. So whenever somebody is typing to Amazon.com, the request directly come to this load balancer or API gateway. This is an ingress controller or ingress load balancer. This is an ingress load balancer, would say. Ingress load balancer. We'll talk about this ingress concept maybe next session or very soon, right? So we'll talk about it. It's a door. Now, whenever somebody types Amazon.com, let's say this cluster is running our Amazon application, Amazon website. So the request will directly come to this load balancer API gateway, and from here, this this will forward this request to service, the cluster IP service. So let's say we don't have auth pod here. Let me create one auth cluster IP. So auth service. So auth service, it is a Kubernetes service now, auth service. This auth service is pointing to auth pod. Let's say my auth pods are running here. I would just take one pod. This is auth pod, authentication pod. So auth pod, the request will go to auth pod, and as of now I just keep one pod. Now whenever I type amazon.com and I put my username and password, the request will come to load balancer or an API gateway which is through Ingress, and this will be forwarded to auth service, and it goes to auth pod and performs the authentication, right? Internally, this amazon.com, whenever you put your what I would say, so whenever you put your credentials, the username and password, so that request will go to authentication. So internally it is path based routing. So what is this path based routing? So amazon.com slash auth, internally it goes like this, the request auth slash auth. So now your Kubernetes ingress rules we will set up. We will write ingress YAML files, ingress rules you will set up. So if it is coming with auth slash auth, amazon.com slash auth, then the request should go to auth service within the Kubernetes cluster. Let's say my request is coming like this. So how it is coming? It is coming like this: Kubernetes amazon.com slash order. So whenever you click on order, internally the request will be processed like this, path based. Then this request will go to order service. So where it is order, this one. So order microservice. Now this order microservice, internally it redirects the traffic to order pod. So let's say somebody types cart, or so somebody types cart or something else, order, so let's say somebody is typing cart. So amazon.com slash cart, whenever you put something into cart, internally it goes as like this, cart, path based routing. Now this request will go to cart service here. Then this cart service will forward this request to cart pods like this, right? So now whoever is entering, they are entering through Ingress load balancer. This Ingress is intelligent enough because we have Ingress rules here. So I have set up, if somebody types amazon.com slash auth, then send the request to auth service. Auth service will send the request to auth pod, which is running in the cluster. If somebody types amazon.com slash order, then the request should go to order service within the cluster, and this request will be forwarded to order pod. So this is how the communication happens, and this is how traffic enters the cluster. Any doubts here? I hope you're understanding.
Yeah, Dayanand.
Yeah. So Abhishek, are you understanding? Yes. Kritika, any doubts here?
No.
Yeah. So now let me go back to Mariano. Am I audible?
Yes.
Yeah. So Mariano, am I audible?
Yeah, what is that noise? It sounds like bombs.
Yeah, here people are celebrating because we won match today. Okay.
Oh, the cricket match. Okay.
Yeah. So yeah, go ahead. So you wanted to discuss something on this ingress, the problem which you faced in your code.
Yes. So when you create an ingress, all it is a YAML file, and he's presenting, and he can because I don't have any. I'm not in my work computer. So you create an ingress file, a YAML file, and the way it works, there's different type of. You need an ingress controller, like he said, and I love that he said API gateway because that's the way of the future. I don't even know how to use it yet. I'm hoping that he'll teach us, but I don't want to confuse you guys. Let's just leave it at the ingress right now. All right. So when I come in, I have to write a YAML file, and that YAML file has, for example, the name of where my application is, and this one was www that it was something for I work for a hospital for medical .k8.com, and in that file I have to point to what service I want to go to, or better yet, what's a good terminology, Gouda? I want to come in through through what service, which is the front end UI for the application, right? And when I was setting it up, everything was set up fine, but it wouldn't work. It wouldn't work. I could only get in with the standard IP address, right? I can only get in through the inside. I cannot get in from the outside. So after troubleshooting for, I think, even days, I called support. I said, listen, this is not working because we use a different ingress called AVI Advanced Load Balancer, which is advanced and very complicated. So it turns out that one of my colleagues upgraded the AVI Advanced Load Balancer from version 30.2 to 32.2. And the next day, it started working automatically. So I spent a week troubleshooting, about a week. So I'm just giving you a perfect scenario how things sometimes, happen in the real world. At the end of the day, I said I have to be doing something wrong, but it's good when things break like that because it teaches you. Can you believe that when he did the upgrade, it started working? So it was a glitch in the software. So I don't know if Gouda, you ever came across something like that, but ingress for me is like I get scared of it sometimes.
Yes, you're right. As already we discussed that updating our applications in the Kubernetes cluster solves many problems at the same time. We also have to make sure we are updating our applications regularly, whether it is an ingress or it is a some YAML releases that you have. Maybe let's say you have deployed your Grafana using YAML, or you have deployed your databases using YAML charts. So as you upgrade your clusters, we also have to upgrade our applications. If so, many times upgrading uh, the applications would solve most of the things. Yes, yes. I've been across. Yeah, we have been facing same issues from a couple of months, wherein our Kubernetes is below 1.2. So we have been trying very hard to upgrade it, and every time when we go with a new upgrade, some things will break. Sometimes ingress will break, sometimes nodes will go down, some nodes will not get connect. So many things will happen at the same time. So so what I prefer from my experience, every 6 months, being a DevOps engineer, we have to upgrade. We have to think about updating our cluster and updating our applications every 6 months at least, once in a 6 months.
So upgrading like the libraries and all that, the packages that you use, right?
Uh, Yes, you're right. So, like, let's say you're using currently Kubernetes 1.2, updating Kubernetes 1.2 to 1.3 because every year or every 6 months they'll release a new version. You have to keep on
Yeah.
updating your cluster. and let's say you have deployed MySQL version, some version, then it's a since you updated the cluster, this will become deprecated. So you have to update your MySQL image as well. Like you have to update it and all other stuff. So you have to make sure you're updating your application, you're updating your clusters. Both goes si- simultaneously.
Okay. So is it that like is this process called patching? Like I'm just trying to understand.
Uh, yeah, you could say, yeah, you could say patch.
Okay.
Yeah. So now, what we have left with that creating the pods in the next session, and that is next Sunday. So next Sunday, we will be creating pods. We will be creating replica sets, and we'll be creating deployments. And in Kubernetes, there are many concepts like we have pods, deployments, replica sets, we have config maps, secrets, we have daemon sets, jobs, cron jobs, ingress controller, and we have node affinity, the PVC, stateful sets. There are many concepts so of which we have to learn. So we will continue this session. We will continue this for another couple of weeks. So where we can also discuss, we can dig deeper, and we can create the spots, and we can create all of the stuffs in a live environment, and we can do all of this. So yeah, what do you think about it? That sounds good.
So better
Yeah,
just one
absolutely.
request. Yeah,
That is
sorry to
excellent.
interrupt.
Oh my
Go ahead.
God, that's like everything. That's beautiful.
Yeah.
Yeah, so then so it will be better you just just record this session so that we can go through if it is required one more time.
Yeah, I have recorded this. I have recorded this session
Good
for
then.
today. Yeah, I have recorded this session today. Maybe I'll upload it somewhere where you all of
Maybe
you
in
can.
Google Drive it will be fine if it is high,
Yeah, yeah. Maybe I'll
supported
update it.
GB or something. Yeah.
Yeah, I'll update it into Google Drive. Then later
Mm-hmm.
on, you can uh, access it whenever you want it. Last time I was supposed to record it, but I forgot to record. This time, yeah, I have recorded and I'll upload it and I'll give access to all of you. You can
No
go
issues.
through it.
Yeah. Thank you very much, then.
Yeah. Okay, then if you have anything to discuss, yeah, we can discuss for a couple of minutes. Maybe I'll give you another 2, 3 minutes. We can discuss. Then we'll end the session here. Next Sunday, again, I'll schedule the continuation part for this. If you guys are interested, we can also discuss about how we can build our own containers and all the Docker stuffs. Let's see how it goes. So we will see that.
Yeah, sure. Even then we can have it like in different environments if we require like Google EKS, like AWS, all those around. Afterwards, like not now, in future if required.
Yeah, maybe
Just to have
you
a hands-on.
Yeah, maybe you all of you can create AWS account and keep it ready. We can create
Yeah,
an EKS cluster and we can deploy live and we can see how we deploy it live onto clusters. We can do that.
yeah, actually. And I'm hoping like Mariano to be there in the next session. It will be really great.
Yeah, yeah. So yeah, every Sunday we will schedule. Every Sunday we'll meet for at least two
Oh yeah,
hours.
this is perfect time for me. I'll definitely be here. I love this. I'm so glad.
Yeah, yeah. I appreciate that. I
Yeah,
appreciate your interest, guys. It really means a lot. So we will keep on moving. So next Sunday again, we'll connect and we'll discuss. We'll continue this part. We'll see how we can create pods and all of this stuffs. And yeah, thank you, everybody. If you have anything, yes, we are open for discussion. Otherwise, we'll end
Listen,
the
what a
call.
great presentation, brother.
Yeah, thank you. Thanks a lot.
yeah.
Means a lot.
Thank you, Dan. Thanks so much.
Thank
Thank
you.
you. Thank you all.
It was great.
Yeah, thank you. Bye bye, everyone. Bye, brother.
Bye.